All right, welcome to this explainer. Today we are tackling a massive and, let's be honest, sometimes chaotic ecosystem, the modern AI stack. If you've been looking at the rapidly evolving world of artificial intelligence and feeling like it's just a giant alphabet soup of frameworks, models, and tools, well, you are definitely not alone. But today we're going to clear all of that up. We're going to approach building an AI system exactly like building a house. You don't start by throwing on the roof. You start with a solid foundation, you frame the walls, you put in the plumbing, and only then do you move in. So we're going to build this logic step by step, literally from the very first lines of code all the way up to deploying a polished, real-world application. So here is the central question we have to answer. Because the reality is, making a raw API call, essentially sending a request over the internet to a large language model and getting a clever response back, that feels like pure magic. But that API call, that is just the very beginning of the journey. A raw model is kind of like a brilliant but highly disorganized genius. It doesn't have memory, it can't access your company's private data, and it certainly can't build a reliable, secure user experience just on its own. To turn that raw model into a production-ready application, we need a complete end-to-end architecture. Okay, let's dive into this roadmap. First, we'll hit core AI programming languages, then move into essential libraries and frameworks, and traditional machine learning methods. After that, the really exciting stuff: Gen AI and LLM orchestration, automating AI tool creation, and finally, web and on-device deployment. Starting off with Section 1, Core AI Programming Languages. Before we can build the walls, we absolutely need to know what materials we're working with. Python is, without a doubt, your absolute must-learn foundation here. Now, actually, it isn't because Python is the fastest language in the world computationally. It's because the entire modern AI ecosystem basically grew up around it. Almost every major AI library and framework is built for Python first. But a well-rounded architect knows there are other materials too, right? If you're working on embedded systems or robotics where that low-level hardware interaction is key, you're going to see a lot of C++. If you need a blend of high-level ease with extreme numerical performance, Julia is fantastic. R remains an absolute powerhouse for deep statistical computations. And of course, JavaScript is essential when you need to execute models directly in web browsers. But for our journey up the stack today, Python is the concrete slab we are building upon. Let's move to step 2. Essential libraries and frameworks. Because once we have our Python foundation, how do we actually manage real-world data? This brilliantly illustrates exactly how that pipeline works, moving from raw training data through the machine learning algorithm right to a trained model and final prediction result. But here is the hard truth. You will spend far more time cleaning messy data sets, dealing with missing data, fixing weird labels, normalizing values, than most tutorials will ever admit. Your model is literally only ever as good as the data flowing through this pipeline. To manage that workflow, we rely on these absolute heavy hitters. For data management, NumPy gives you the power to handle massive, complex grids of numbers, while Pandas provides data frames to manipulate and clean all your tabular data. Once that data is pristine, you might move over to Scikit-learn. That's the gold standard for traditional machine learning algorithms, things like regression and clustering. But when you need to build complex neural networks and really dive into deep learning, that is when you bring in the massive frameworks. TensorFlow, which is highly optimized for production environments, or PyTorch, which has become incredibly popular for its flexibility and dynamic computational graphs. All right, Section 3, Traditional Machine Learning Methods. Because before we jump straight up to the flashy penthouse of generative AI, we really need to understand the internal plumbing. We have to strategically contrast the two because not every problem requires a massive, expensive language model. Traditional AI is phenomenal at learning from historical data to predict outcomes or classify information. So if you need to identify spam emails, predict housing prices, or forecast next quarter's sales, traditional AI is exactly what you need. It's highly efficient. Generative AI, on the other hand, is all about creating entirely new content based on patterns. That could be summarizing a 50-page legal contract, generating images, or doing complex reasoning. Honestly, the best enterprise systems actually combine both, maybe using traditional AI to predict customer churn and then Gen AI to draft a highly personalized email to win that specific customer back. Let's move to step 4, Gen AI and LLM orchestration. This is where we bridge that gap from a raw model to a useful application. And this brings us to what is arguably the most important architecture pattern in modern AI, Retrieval Augmented Generation, or RAG. Remember how we said an LLM is isolated? RAG is how you give that LLM an education on your specific domain. It works by taking your private documents and converting them into embeddings, which are basically mathematical coordinates that capture the true semantic meaning of your text. We store those in a vector database. When a user asks a question, the system uses semantic search to find the most relevant chunks of data, not just keyword matches, but actual contextual meaning, and then passes that specific information to the LLM right before it generates an answer. This grounds the model in your reality and practically eliminates hallucinations. So, how do you wire all of that together? You use an orchestrator. Think of LangChain as the ultimate Swiss Army knife. It's incredibly versatile, perfect for building complex agent workflows where you're chaining different tools together. LlamaIndex, meanwhile, is your laser-focused specialist. If your primary goal is getting private data into your LLM through deeply indexed RAG pipelines, LlamaIndex is unmatched. And Haystack really shines for robust, highly controlled search pipelines in strict enterprise environments. The real secret cheat code of modern AI stacks, though, using them together. You might use LlamaIndex to handle the heavy data retrieval, and LangChain to manage the agent's logic. On to Section 5, Automating AI Tool Creation. We're moving beyond simple scripts now into autonomous systems. To understand this, let's break down a super popular open-source framework called CrewAI. Instead of one AI trying to do everything, you essentially build a virtual team. Step 1, you define agents. You give them specific roles, like a senior research analyst, complete with a backstory and a goal. Step 2, you define tasks, which are specific work items with expected output formats. Step 3, and this is crucial, you give them tools. This is the ability to execute code, search the live web, or read a database. Finally, Step 4, the crew. This is the orchestration logic that ties it all together, managing how these agents communicate and pass work back and forth to solve complex problems that a single prompt could just never handle on its own. Finally, Section 6, Web and On-Device Deployment. We have our foundation, our agents. Now how do we get this into the real world? You really have to choose between a cloud API approach and on-device deployment. Cloud APIs, like hitting OpenAI or Anthropic servers, give you access to massive, incredibly capable models. But they come with high recurring costs, they fail completely if the user loses internet, and every query means sensitive data is leaving the device. In healthcare or finance, that's a massive privacy risk. On-device AI flips the script entirely. You download the model directly to the user's phone. Data never leaves the device, it works perfectly offline, out in the field, and the latency is incredibly low. The trade-off? Well, current mobile devices can only run models up to about 7 billion parameters. Think of parameters as a measure of the model's brain power, so you do sacrifice some of that massive reasoning capability. Now, what's really interesting here is the stark financial reality when you hit enterprise scale. If you build an app with 100,000 daily active users and they each run just 5 queries a day, relying on cloud APIs is going to cost your company anywhere from $36,000 to over $360,000 every single year in recurring fees. Compare that to on-device deployment. Yes, it takes way more initial engineering investment to build and optimize it, but once it's deployed, your ongoing inference cost is exactly $0. That gap makes this one of the most consequential architecture decisions you will make. We have covered a tremendous amount of ground today. From that foundational Python code to data processing libraries, understanding when to use traditional ML versus LLMs, architecting RAG systems, deploying multi-agent crews, and finally making that critical choice between cloud and on-device deployment, you now have the complete blueprint for the modern AI stack. The only question left is, with all these incredible tools at your disposal, what are you going to build first?